Hi everyone, my name is Miguel.
My name is Kat.
My name is Katherine.
My name is Robert, and we are Team 1, which in our device is the PresSense.
Just some context for the need for our device.
Hypertension or high blood pressure affects nearly half of all adults living within the United States. It is a common condition known to increase the risk of heart disease and stroke, with both currently being the leading causes of death throughout the country. People living with hypertension and at risk for developing these health complications are often required to closely monitor their blood pressure throughout various points of the day. The current line of blood pressure monitors offer a limited range of flexibility for where and when these measurements can be taken. We realize that good user experience maximizes the probability of consistent monitoring. This is why we went ahead and developed PresSense, a novel blood pressure monitoring device. Our final and original vision for PresSense includes a compact wearable device by which an individual with hypertensive conditions can take blood pressure measurements from the convenience of wherever they may be. For now, we introduce our functional prototype.
PresSense currently works over a wired connection and includes a seamless user interface through which the user can take multiple actions. The device itself includes a blood pressure cuff and the diagram of a stethoscope extending from the box containing electrical hardware equipment. We use a micropressure sensor to detect pressure changes within the cuff as it is inflating and deflating. We then use a microphone to detect the changes in blood flow through the user's brachial artery to isolate systolic and diastolic blood pressure values. We will now go through how one would use the PresSense blood pressure monitoring device.
The user begins by entering the PresSense program on the Lobby front panel. Upon entering, the user now has the option to log in or create an account. Katherine P. will go ahead and log into her existing account. The user is now taken to their home page in which they can choose to take their blood pressure, view their history, or log out. In this case, Katherine wants to access her previous measurements, so she will click View History. Katherine's blood pressure history is presented on an HTML report with a table and graph displaying her previous measurements. This report can be downloaded from the internet and saved in case Katherine's physician may want to receive a copy. Katherine can now resume to the main flow of the program by exiting out of her default browser. Now that Katherine has returned to the program, she can go ahead and take her blood pressure. She is redirected to a new page with a set of instructions. From the text and these images, Katherine will place a blood pressure cuff and stethoscope on her arm accordingly. Once she is set up, she will click I'm ready to measure my blood pressure. The program redirects Katherine to a new page in which she selects the serial port through which the device is connected. Upon this selection, the device begins taking measurements, and the status of this process is displayed on the screen. This process usually takes between 1 to 2 minutes, so we will go ahead and fast forward to the end of the measurements. Katherine is automatically redirected to a page with her results when the device is done taking measurements. She now has the option to save these current measurements to her file or to scrap them and return to her home page. This then concludes our demonstration.
While we weren't able to make it super compact and wearable in the end, we are proud of all the work that we did achieve in this really short semester. In particular, we are really proud of our hardware and software integration, for which we primarily used a state machine in LabVIEW to communicate with all our hardware. And we were able to call on these processes from the main VI or the user interface without running into any errors, and thus we're able to deliver a seamless user experience. And Robert can speak to his use of the hardware and success in signals processing.
So our device's hardware we're really proud of as well because we've created a device that has switching capabilities to easily create the kind of environment that you need to run blood pressure measurements. We used components salvaged from an existing blood pressure monitor, which were very well equipped to work within existing structures. The signals processing side of our project took a lot of time and effort, but we were really proud of the results. We decomposed our signals into different spectral bands. Using a spectrograph, we analyzed which were the relevant bands in the blood pressure measurement signal. Using this spectral information, we found an accurate signal to represent both the beginning and end of the heartbeat transient state.
And to Dr. Merrick and all the TAs who helped us with our project, we just wanted to give a big thanks to all of you.